All right, good morning, guys. This week we're going to talk about exponential functions. We've talked about linear functions, those are the ones that graph straight lines. We've talked about quadratic functions, those are the ones that give us the parabolas. We've talked about those the last couple of weeks. Today we're going to talk about exponential functions. Okay, and exponential functions give us a curve, sort of like this, or like this. Okay, the function looks like this. F of x equals a times b to the x. So you'll notice that x is our exponent. A is our initial amount. And b is the rate of growth or decay, the rate of change. Okay. And we'll talk about that more later. But what we're going to do is an activity that normally I would do in class. I have two favorite exponential functions activities, and I know what a big nerd that makes me sound like. But there's one we do with M&Ms, but I'm currently out of M&Ms. The other one is where we model a zombie outbreak. And I'm also binging Walking Dead recently on this little vacation from school, so the zombies are on the brain. So here's what we're going to do. We're going to imagine there was a zombie outbreak at Southwest High School. Okay, Mrs. Kruger is a zombie. She brings it into the cafeteria during B lunch. On day 1, I infect one student. And then on day 2, both zombies, that's me and my zombie student, infect another person. And we're going to go through the scenario and look at what the data would look like if every zombie infected one zombie a day, or infected one new person a day. So keep in mind, this is a pretend scenario. There are no real zombies, okay? And for data purposes, we're going to make these following assumptions. We're going to assume there are 900 people in B lunch, including me. We're going to assume that all 900 people come to lunch every day and that we're only infecting people at lunch. So it's not spreading anywhere else throughout the school. We're only looking at the cafeteria during B lunch. Okay. So our instructions are use the table below to track the zombie outbreak and then plot the data on the given graph. That's what we're going to do next. Okay, so looking at tracking the outbreak. We're always going to start on day 0. So at the beginning, Mrs. Kruger is the only zombie. So on day 0, we have one zombie. On day 1, I am going to infect one person. So let's say that I infect Amari. So now we have 2 zombies. Okay. On day 2, I'm going to infect someone, and Amari's going to infect someone. So let's say I infect Casey, and Amari infects Josiah. So now how many zombies do we have? 1, 2, 3, 4. 4 zombies total. Okay. Well, on the next day, all 4 of these zombies are going to infect someone new. Amari's going to infect someone. Josiah's going to infect someone. Casey's going to infect someone. I'm going to infect someone. So now we have 4 new zombies. Altogether, that's 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, we could keep drawing arrows and circles all day long, but I'm a little bit lazy. I would rather look for a pattern, so I'm going to ask myself, what's happening to these numbers as I go? Okay. What pattern do we find? Well, I can get to the next number by multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So instead of drawing this awesome little web here until the whole paper is covered and I start counting wrong, we can just multiply by 2 all the way down the line. Okay. So we are going to double the numbers as we go. 8 times 2 is 16. Times 2 is 32. Times 2 is 64. Times 2 is 128. 256. And 512. So, as you can see, we started out with 1 zombie, and in 9 days we had 512 zombies. So you can see that what happens with this function is it starts to really increase rapidly the further down we go. All right. So we see what our table looks like, but now we also want to see what it would look like if we graphed it. So let's plot our data. We have our x-axis here. This is going to represent the number of days. Okay, and my table only goes from day 0 to 9, so I'm just going to go by ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and our people infected went from 1 to 512. Now we may not go all the way up to that. We may not fit it all on our table. On our coordinate plane, but our y-axis here is going to represent the number of zombies. I'm going to go, let's go by 10. That's not going to get us quite all the way up to the 512, but let's go 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 150, 200 right up here. Okay. Now, if you did this on your own without going through the video, you might have used different numbers on the axes, and that's okay. But I'm going to go ahead and plot these points. Day 0, I had 1 person infected, and that point's going to be way down here. Day 1, I had 2 people. 2, we had 4. 3, we had 8. So far, it's just barely creeping up. It doesn't really look like we have much of a problem. But look what happens here now. 4 goes to 16. Day 5, we have 32. Day 6, we have 64. 50, 60. Day 7, we jump to 128. 10, 20. And day 8, we're off the chart. 256 would be somewhere up here. Okay. So if we were going to plot this, okay, it starts off gradual, but then the further we go, the faster it jumps. Okay. This is what an exponential function does. Okay. So I want to answer a few questions you see down below. A says, describe what is happening to the number of infected people each day. Well, when we looked at our table, we saw that we were multiplying by 2. And another word for multiplying by 2 is doubling. Okay, so we'll say the number is doubling each day. No big deal when we go from 1 to 2 and 2 to 4, but you can see that about here it starts to really jump. Those are big increases every day. Question B, is this data linear, quadratic, or exponential? Well, linear means it would graph a straight line. Quadratic would graph a parabola. Exponential gives us a curve similar to what we saw here. So this is definitely an exponential situation. Question C says, write a function that could represent this data. So on the very beginning of the notes, at the very beginning, before we talked about the zombies and instructions, we said that f of x equals a times b to the x, where a is the initial value, it's what we start with, and b is our rate of growth or decay. So our function is going to look like this. Y equals our initial value. So how many zombies did we start with? We started with 1, just Miss Kruger. So 1 is our initial value, times, we said that it is doubling, so that's going to be times 2 to the x power. So that's our function that would represent this data. If we went into Desmos or on our calculator and graphed this, we would see a curve that would follow this data here. And we would see a table that has the same numbers we had here. And the last question for this portion of the notes, if our school has 900 students in B lunch, how many days until they are all infected? Okay, well, if we go back up to our table, we were at day 9 and 512. If we went one number further, let's go to day 10. and we doubled, 512 times 2 would be 1,024, which is more than what we have in lunch. So in 10 days, we would have infected all 900 students. Okay. So again, this is not something you have to turn in for a grade. This is just to kind of help you understand what exponential data looks like. If you have any questions, don't forget to check in with me this week. Send me a message, send me an email, text me on Remind, whatever you need to do, or check into one of my Zooms. We are going to, in the next video, we're going to talk about fighting the zombies. What happens if we start decreasing the numbers exponentially? So tune in to the second video to see what happens when we fight the zombies. Y'all have a good day.